So I left off last time showing you how to graph these inequalities. Now remember, graphing the inequalities, there are a couple pieces. One of the pieces here, we're going to graph it first as a line. It's going to be a solid line if it's less than or equal to or greater than or equal to. That equal to piece means it's a solid line, and I'll explain more about that later. If it's less than or greater than, no equal to, it's a dotted line that we're going to graph. Okay. The next piece that you're going to do is, notice this is y is less than 4. So any y value that is less than 4 is a solution to this sentence. Makes it true. So here's y equals 4, and all the y values, so on the y-axis, less than 4 make this statement true. So all of these values would make this statement true. Over here, same deal. Once I've plotted this, just like I would a line with the y-intercept, and then using this number here, 2/3, as the slope, rise 2, run 3, to find other points on the line, I shade the side of the line where the points make this statement true. So for instance, if I put 0, 0 into this equation, it would look like this. Instead of y, my point I'm going to choose is 0, 0. That's the origin. It's this point right here. If I plug that into this equation, instead of y, I would have 0 is greater than, and instead of 2/3 x, I would have 2/3 times 0, because that's also my x value, minus 2. And then I'd simplify. The 0 is greater than, that would be 0, minus 2, and keep going. 0 is greater than negative 2. 0 minus 2 is negative 2. Is it true? 0 is greater than negative 2. Is that a true statement? Yes, it is. So we shaded the right part. So there's a way for you to check, okay? So, and here's a helpful remark here if you need a clue to help you out. So looking at these two examples, excuse me, I had to sneeze. Looking at these two examples, they're different from the example number 4, because example number 4, it looks like it's already in slope-intercept form, y equals mx plus b. But down here, it's in standard form. X and y are on the same side of this inequality. So before we can proceed, we need to solve for y and get y by itself. So here's how we're going to do that. We are going to, the easiest way I can see is, because y is already negative here, we're going to add y to both sides of this inequality. It doesn't flip the sign at all. And what that will be 2x is greater than or equal to 1 plus y. And I'm going to go one step further. I'm going to move the 1 over here by subtracting it from that side and subtracting it from this side as well. So that leaves me 2x minus 1 is greater than or equal to y. And I don't have to flip the sign because I did not multiply or divide by a negative number. So now that we have this equation in slope-intercept form, we're going to take this y-intercept here, and we're going to plot it, so that's negative 1. And then we're going to take our slope, which is 2 in this case, so I'm going to rise 2 and run 1. And that'll be what I plot. Now, before I create the line, let's make sure what kind. Is it going to be solid or dotted? Well, it says greater than or equal to, so that means this is going to be a solid line. So we're going to create a solid line here. Okay. So we have our solid line. Now which way do we shade? Well, let's see. Y is on this side. This piece has to be bigger than or equal to y. Now if that doesn't make sense, let's just flip it. Let's put y on this side and 2x minus 1 on this side. But if we flip that, we can't keep the sign the same. We have to flip the sign as well. Okay, so notice how if I flip the sides, I also have to flip the sign. So this says y is less than or equal to 2x minus 1. Well, all the values on the y-axis less than this line. So this is the side we're going to shade. Therefore, this is the side of the graph we're going to shade. Okay? Let's try another one. Example 5. So we're going to graph this right here. So because y is positive, it's okay. We'll just keep it on the side. We're going to subtract x from both sides right here. So we're going to subtract x from both sides of my equation. That leaves me 3y is greater than 9 minus x, and we're going to divide by 3. So divide both sides by 3. That becomes 1 times y, which is y, greater than, don't have to flip the sign. This isn't a negative number I'm dividing by. I'm going to divide 9 by 3, which is 3, minus 1 divided by 3 is 1/3. Alright, let's graph this. So this is positive 3 for my y-intercept. So we're positive 3. And negative 1/3. So negative 1 over 3. Okay? Or I could have done positive 1, but negative 3. Okay? So I'll go up 1 and to the left 3 instead of down 1. This is the right 3. Now, this is not equal to, so it's a dotted line. It's my best dotted line. And then we need all the values of y greater than this. So everything greater than this, so that my y-axis is greater. That's the greater part of my y-axis. Alright, so, and I just showed you how we can test out if these points are solutions to example 6. So let's see, 3, 2. So I have this equation here, so I'm going to plug in 3 for x, 2 for y. So this is y, so we're going to 2 is less than or equal to 2 times x. X is 3, so multiply it times 3 minus 1. Simplify it, 2 is less than or equal to 6 minus 1. 2 is less than or equal to 5 minus 1. Alright, so this is a true statement. 2 is less than 5. So this is a point that is a solution, alright, to this inequality here. This point is in the shaded region, so it is a solution. Negative 2, negative 2. Now, let's try this one just by looking at the graph. So we're going to go negative 2 and then down negative 2. That's this point right here. It is not in the shaded region, so it is not a solution. Okay? Let's try 3, 2 just to check it. Positive 3, positive 2. So that point is in the shaded region, just to prove the point. But you can always plug it into the inequality if you'd like. Negative 1, negative 3, negative 1, negative 3. That is on the line. It is part of the solution because that line is solid. Alright? And we already answered these questions, so you're good. So moving on. Alright, so this is an application problem. And what you're going to have to do is you're going to have to try this bottom piece right here. But this top piece is done like so. In the problem about 8th graders selling t-shirts for $5 and caps for $10, they had to, that word got cut off there. They had to try those t-shirts for $2 and caps for $5. If they only had $200 to buy items to sell, how many of each could they afford? So excuse me, I messed up. This is buy those t-shirts for $2 and caps for $5. So before they sold them, they had to buy them, so so that they would have something to sell. And they only have $200 to buy items. So how much could they afford of the caps and the t-shirts? So write an inequality to represent this expression. So let's say T is for t-shirt and C is for caps. Okay? So if it's $2 per t-shirt, okay, and it's $5 per cap, total, I cannot buy more than $200. Okay, $200 is my limit. I cannot buy more than $200 worth of caps and t-shirts. So that means this piece right here has to be less than $200. Because if this piece right here is greater than $200, then I've gone over my budget. So if you only bought shirts, how many could you buy? Well, that's not bad. These are t-shirts. So let's say we only buy t-shirts. That means we don't buy any caps. So I'm going to leave that piece out. Now, in order to solve the inequality, I just divide by 2. And that means I can get less than 100 t-shirts. Could we also get equal to? Sure. So it could be less than or equal to. Because if we're right at $200, that would work as well. So we could buy 100 or less t-shirts with our amount. Okay. If you only bought caps, how many could you buy? So same deal, $5 for each cap. Has to be less than or equal to $200. I'm leaving out that T part because I'm not worried about t-shirts. You divide both sides by 5, and what you end up with is 40 caps. Okay, so you can buy 40 caps. Express these numbers as ordered pairs. These are your x and y intercepts. So if this is shirt, so instead of S they used, instead of T they used S, and here they have caps. That's okay. So as ordered pairs, so this is my y-axis and this is my x-axis essentially. T-shirts is my x-axis, so I would say 100, because that's the x part, to 0, which would be my x-intercept, but that's way off the grid. And then for caps, it would be 0, so that's on my x-axis, 0, and 40. So my y-intercept here is 40. Okay. Using the graph for inequality, test a point to decide which side to shade. So let's see, if we kept going here, we'd probably end up about right here. Okay. Alright, there's our line. Because it's equal to, it's a solid line. So now we're going to test a point to see if it's true. So let's pick a point. Let's pick 2020. Alright, so what I'll do is I'll put 2020 into my inequality. So we're going to say $2 times 20 plus $5 times 20. I just picked any random point on the grid, and that's going to be less than or equal to $200. Alright, so that would leave me 40 plus 5 times 20, which is 100, equals 200. Add this together is 140. Is less than or equal to 200, and that is a true statement. So this is the side we're going to shade, the side with that point. Okay. List possible solutions to your inequality. Any of these points right here would be possible solutions, and any point on this line would also be possible. So don't worry about writing that. Why are we only looking at the first quadrant? Because you can't sell negative caps or negative t-shirts. It doesn't make sense in the context of the problem. So it says for you to try. You go ahead, you try that out. And then right here, this is the last piece. This is graphing linear inequalities. You can put your name, date here, but it's not necessary. These are steps to how to do it. If it's first you need to figure out if the line is solid or dotted. Again, all you're doing is graphing both lines on the graph at the same time, and then shade it above and below each graph individually. All right, so this is solving systems of linear inequalities. So here's how this one works. And I'll demonstrate this in another video so it's not so long.